You may have seen node link diagrams involving more than 100,000 nodes. They purport to show a visual representation of the network, but in reality just show a hairball. In this section, we're going to look at alternate ways of visualizing network data that are much more rational. I'm going to introduce you to 3 different types of network visualizations. The first is visualizing a network using a matrix plot. The second is what we call an arc plot, and the third is called Circos Plot. Let's start first with a matrix plot. In a matrix plot, nodes are the rows and columns of a matrix, and cells are filled in according to whether an edge exists between the pairs of nodes. On these slides here, the left matrix is the matrix plot of the graph on the right. In an undirected graph, the matrix is symmetrical around the diagonal, which I've highlighted in gray. I've also highlighted one edge in the toy graph, edge AB, which is equivalent to the edge BA. Likewise, for edge AC, it is equivalent to the edge CA because there's no directionality associated with that edge. If the graph were a directed graph, then the matrix representation is not necessarily going to be symmetrical. In this example, we have a bidirectional edge between A and C, but only an edge from A to B and not B to A. Thus, we will have AB filled in, but not BA. If the nodes are ordered along the rows and columns, such that the neighbors are listed close to one another, then a matrix plot can be used to visualize clusters or communities of nodes. Let's now move on to arc plots. An arc plot is a transformation of the node link diagram layout in which nodes are ordered along one axis of the plot and edges are drawn using circular arcs from one node to another. If the nodes are ordered according to some sortable rule, for example, age in a social network of users, or otherwise grouped together by geographic location in a map for a transportation network, then it will be possible to visualize the relationship between connectivity and the sorted or grouped property. Arc plots are a good starting point for visualizing a network as it forms the basis of the later plots that we'll take a look at. Let's now move on to Circos plots. A Circos plot is a transformation of the arc plot such that the two ends of the arc plot are joined together into a circle. Circos plots were originally designed for use in genomics, and you can think of them as an aesthetic and compact alternative to arc plots. You will be using a plotting utility that I developed called nxviz. Here's how to use it. Suppose we had a graph G in which we added nodes and edges. To visualize it using nxviz, we first need to import nxviz as nv and import matplotlib to make sure that we can show the plot later. Next, we instantiate a new nv.arcplot object and pass in a graph G. We can also order the nodes by the values keyed on some key. Finally, we can call the draw function, and as always, we call plt.show. The example code here shows you how to create an arc plot using nxviz, and you'll get a chance to play around with the other plots in the exercises. All right, let's get hacking.